Hi guys, Mark here and welcome to day 11 of the Advent of Code Challenge. I'm hoping you get to watch today's video. Unfortunately, YouTube decided to reject yesterday's video saying that it contained inappropriate content. I've got absolutely no idea why that happened. Anyway, today's challenge is all about helping Santa to choose a password. Basically, he has to change his password, and he does so by incrementing his old password. So if it ended in A, then he changes it to end in B. And it wraps around. If it ends in Z, then it goes back round to A and the previous letter goes up by a letter. And basically, there are a number of restrictions on what password Santa can choose. And so many of the password candidates he comes up with are invalid, so he has to keep on incrementing it. And you can see here there are 3 rules for what constitutes a valid password. There are some letters you can't include, you need at least 1 increasing straight, and there must be 2 pairs of non-overlapping pairs of letters. So let's have a quick look at how I solved this initially in C#, and we'll look in LinkPad. Basically, there are 2 parts to the problem. The first part of the problem is generating your password candidates by incrementing the current password, and the second part is then checking those candidates to see if they're valid. Now the second part is perhaps the easier part because we've already done something like this on day 5. You could do it with regular expressions, or you could just write custom code. But for the first part, you can go in 2 directions. You could just manually increment the password by starting at the last character, incrementing it, and if it was Z, then going to the one before and incrementing that, and so on. Or you could say that the password is actually a base 26 number. So you take the string, interpret it as a base 26 number, turn it into an integer, add 1 to the integer, and then turn it back into a base 26 string. So that's the approach I decided to go with. I'm not sure it was necessarily the right one to pick to start with, but that's what I came up with. And so to convert it from a base 26 string into a long, and it needed to be a long, otherwise it would overflow, I reversed the characters, and then I used link's aggregate method. And my accumulator consisted of a sum, so the current total of all of the digits in the base 26 number, and the multiplier for this position. And so as we go through each character in the string from the right hand side, we add to our sum basically the value of the current character times the multiplier, and then we multiply the multiplier by 26. So we're getting increasing powers of 26, and then we access the sum. Then of course we've got to be able to go the other way, and so the way I do that is I've got an array of all the characters in the alphabet, and we start with the number and we mod 26 it to find which character at this position, and then we divide our number by 26, and we keep going while the number is greater than 0. Now this does kind of have a little bit of a flaw, and that is if the password begins with A's, the converted to base 26 won't actually have those A's at the beginning, because they're like zeros. So I could have padded this afterwards with some A's at the beginning, but it turns out I didn't need to. So to increment the password, we convert it from a base 26 string into a long, add 1, and then convert it back into a base 26 string. So now what we've got to do is check that it's valid, and you can see here I've got a few little test cases that are commented out as I was testing my work as I went along, which is always a good idea to do. So there are 3 conditions. First, does it contain an increasing sequence? And so I used substring to get myself all of the 3 character ranges in the password candidate, and so then I could check whether any of them had the conditions that they were consecutive. So the second letter was 1 after the first letter, and the third letter was 1 after the second letter. I also needed to check whether it contained the naughty letters I, O or L, and I did that again with link. And finally, I did fall back to regular expressions for contains two non-overlapping pairs. And there was a very similar problem earlier in this advent of code where we learnt about this \1. So find me a character and then find me exactly the same character immediately after. And so there's a pair, and then 0 or more characters separate. Find me another character and exactly the same character repeated after that. Now actually, I misinterpreted the instructions. I thought it was more complicated than that. I thought that these two pairs of letters had to be different. So if this one was AA, then this one couldn't be AA. It had to be BB or something. And so I counted all of the pairs of letters and checked that there was more than one distinct pairs of letters in the string. It turns out that it didn't make any difference. I still got the right answers. But actually the real problem was slightly simpler. And so finally, we can check if it's a valid password because it doesn't contain any naughty letters, it contains an increasing sequence, and it contains two non-overlapping pairs. And so then all we have to do is start with our starting number, which I convert from the beginning password, and then for an arbitrary number of password attempts, I'm allowing Santa 10 million tries, I'm going to select the next number, convert it to a base 26 string, and check if it's a valid password, and return the first one that is. And that absolutely works fine. We get the right answer. It's not a particularly concise solution, this. And so I initially converted this to F#, taking a fairly similar approach, but I did a bit more work on my F# this time and tried to tidy it up a little bit and make it a bit more concise and also use a different approach. So let's have a look at the F#. So what I decided to do with the F# was actually write the password candidate generator myself. And so I made this, first of all, I made this dictionary of lookups. For any character, get the next character to increment to. And so you'll notice I've taken the letters in the alphabet but already excluded I, O and L, which are invalid characters. Then I've used sequence.pairwise to get every pair, A and B, B to C, C into D. And then I pipe that into the dict function, which takes a sequence of tuples and it interprets them as key and value. So I've got a dictionary that tells me what the next letter should be after each letter. And I don't actually need Z to A because of the code that I've written elsewhere. Also, to try and keep my code a little bit more concise, I just defined an operator that appends a character to the beginning of a string. Unfortunately, because F# is quite fussy about type safety, you can't easily append a character to the beginning of a string like you can in C#. So I added this method. But then the way that I increment the password is I reverse the password and then I use sequence.fold, which is kind of like links aggregate. And you take basically a folder function and some starting state. And the way I've done this is that in my state, the state has a flag essentially to indicate whether we're carrying over and the current new password. And so in the folder, if we're not carrying over, then we just append the current character onto the beginning of the new password. If we are carrying over and the letter was a Z, then we're still carrying over and the new letter at the beginning is an A. And if we are carrying over and the letter is anything else other than a Z, then we're not carrying over anymore and we just append the next character from our lookup dictionary onto the beginning of the string. And then I wanted to create a never-ending sequence of new passwords, and I can do that with the unfold function. So I can say that I want to basically keep repeating this function again and again, and unfold basically allows us to keep repeatedly calling this next password function. And so we're able then to get this sequence of password candidates. The first one is actually the original value, so I have to skip that. Now the naming of this function suck, that actually comes from an answer I saw on the subreddit. Someone had solved this fantastically in Ruby in just 2 lines, and they were able to do so because Ruby's got this successor function that basically already does this password incrementing exactly as needed, and it's built into the library, so they were able to do it much more easily. But I like the name successor, so I thought I would borrow it for my F# code. So now we've got the ability to generate a sequence of password candidates. We just need to check them. And again, for succinctness, I've used this operator again for testing a regular expression. And I decided I'd use regular expressions for all of the tests. So to look for a run, what I've done is I've taken all the letters A to Z. I've used the sequence.windowed function to give me them in arrays of 3, so ABC, BCD, DEF, and so on. I then map those little arrays into strings, so I've now got ABC, BCD as strings, and I concatenate them all together with a pipe. And so basically that gives me the input for that regular expression. And then I also use the regular expression to look for 2 non-overlapping pairs. I can leave out the regular expression to check for the invalid characters because I'm not using them in the passwords that I'm generating. So as long as the original input doesn't contain an invalid character, none of my password candidates will. And so finally, to find the next one, I need to call the password candidate generator function and pass that into sequence.find for an isValid password. And I did a few tests and it all seems to be working. As I've said a few times before, my F#, particularly in LinkPad, seems to run a lot slower than my C#. I don't know whether that's a quirk of LinkPad or something I'm doing wrong in the way that I'm creating my algorithms. But I'm fairly pleased with this F# algorithm. It's more succinct perhaps than most of the F# code I've written in the past, and hopefully I'm beginning also to use a bit more of the language, which is part of the reason for trying to attempt these problems in F# as well as C#, which I'm much more familiar with. Anyway, thanks for watching. If you could give this video a like, that would be great, because I need to persuade YouTube that I'm not uploading dodgy videos that they need to take down. But thanks for watching, and maybe hopefully I'll see you for tomorrow.